Hello, welcome to the Quiz 8 review. So, looking through this, there's some things that you definitely need to know. So it has at the top, you need to know and be able to use the theorems that we've talked about. So intermediate value theorem, this is an old one, but it's coming back, so make sure that you know this. Extreme value theorem, absolute mins and maxes. Rolle's value theorem, we can go through the rest of this, but where f prime of c is equal to 0, mean value theorem, the average rate of change is equal to the instantaneous rate of change. So what you need to do is be able to apply these major theorems given graphs, equations, and or tables. So if you haven't done your homework, do it. Make sure you are totally caught up because this will help you. Also, try this review. This will also help you. So quiz 8, here it tells you what free response is. It requires that you justify your solution using one of these theorems. So you need to actually list it. You will need to find the derivative and interpret the derivative using correct units. So that's one of those, like, I think we just did one in class today. The R of T1 was talking about the flow of water going out of a tank, and then R prime of T was the rate of change of that flow. That's what I'm talking about there. Okay, so here, this stuff is important. So look over that, make sure your homework is complete from 1 to 29. Average rate of change versus instantaneous rate of change, that stuff, important. If I'm writing on here, what happened was I make this by just going through a quiz and saying, hey, these are things that I think they should know. So make sure you do. Okay, so let's try this. So the first one, let's G be a function that is continuous on the closed interval from 3 to 8. So I'm seeing continuous. Just because it's continuous doesn't mean it's differentiable. If it said differentiable, it would mean also continuous. On the closed interval from 3 to 8, g of 3 equals 18, g of 8 equals 27. So this one's saying, what theorem guarantees g of x is 22? Has one at least solution on the open interval from 3 to 8. So if you see where g of 3 is 18, this is g of 3, let's say this is 3, 18 being way up here somewhere. And then g of 8 is 27, so way up here. See how 22 is in between 18 and 27? So I'm going to say g of, or I'm sorry, not g of 2. I said 2 because it says 22 here. G of x is 22, is between 18 and 27. So I can say over here g of 3 is less than g of x is less than 27. I'm sorry, g of 8. And I'm getting all this from up here. What I'm going to do though is say, if I'm talking about a theorem guaranteeing this, I'm going to say as g of x is continuous, then I'm going to say that, and I see that 22 is between 18 and 27, then there also exists a c in between a and b such that g of c equals 22. I don't know what that value is, but this makes sense. G of x is somewhere 22. And so this is guaranteed by intermediate value theorem. So I'm saying that g is between these two, and I'm also saying g of x is continuous. So the conditions for IVT2 apply. The next one, what theorem guarantees that g of x has a maximum on the closed interval? So if I'm talking about maximum and minimum, those are extrema. So this would be the extreme value theorem. So extrema, maximums. So in this one, because again, the function is continuous, as g of x. I don't need differentiable or anything else, as g of x is continuous, because I see it up here. Extreme value theorem applies. If I want to see if Rolle's theorem or mean value theorem apply, for both of those, our function needs to be continuous and differentiable. And this one, because it just says continuous, I don't know if this function is differentiable or not. So I'm going to say G is not said to be differentiable, like we can't figure out if it's differentiable based on the information. Therefore, Rolle's theorem cannot be applied. You might be saying in this one, G of 3 does not equal G of 8, and that would also be another reason. Same thing with mean value theorem. I'm just going to say same thing as above, except for mean value theorem can't be applied, because G of X is not differentiable, or at least I don't know it is. There's no way for me to figure that out just based on what was given. If you turn this over to the back, it gives an equation that says let h of x equal 2x cubed minus 3x squared. Find the value of c that satisfies the conclusion. So the conclusion of the mean value theorem is this. You know when it says f of b, that's an f, minus f of a for b minus a for some value f prime of c. So that's what we're looking for. Sorry, that's hard to tell, it's an f. Now it looks even worse. So in this one, if I did that same thing and I did h of b minus h of a over b minus a, I would say h of 3 halves minus h of 0. And if I actually do that, I put in 3 halves here and then I put in 0 here. I'm going to skip ahead a little bit because I've already done it. You can see some work on this page. I get that I have 0 minus 0 over 3 over 2, or I could say 1.5. So this is going to be 0. 0 divided by anything is 0. That means 0 is going to equal f prime of c, or in this case, h prime of c. And I need to figure out that value of c. So here's h of x. I'm going to take it and find the derivative. And I get 6x squared minus 6x. And I can see somewhere this derivative is going to be equal to 0. So I find it. And I see the places where that happened would be at x equals 0 and x equals 1. But the c that's guaranteed is going to be in this interval, and it's in the open interval from 0 to 3 over 2. So 0 doesn't count. So the c I have been looking for would be c equals 1. There could be more than one, but in this case, it's just the one in the interval. Well, in all times, it's the one in the interval. Okay, the next one. If the graph of y equals x cubed plus ax squared plus bx plus c, or plus 3, has a point of inflection at negative 227, what is the value of a? Right now, I could put in negative 2 for x and 27 for y, but I would have an a and a b variable both. This is talking about the point of inflection. Remember, points of inflection happen when the second derivative changes from positive to negative. So y double prime changes positive to negative, or negative to positive. If it's changing from negative to positive or positive to negative, what really is happening is that in most cases, there's a few times where the second derivative does not exist, but in something like this, where it's a polynomial, that means the second derivative is going to equal 0. And I can see that's happening when x is negative 2. So if I go over here and I find y prime, I would get 3x squared. This is, a is just considered a coefficient, so I'm going to have 2ax plus b. And then if I take the derivative again, so I can get to y double prime, where I know it's equal to 0. That's hard to tell over there. Now I would get 6x plus 2a, and the derivative of any constant is just 0. Now if y double prime is 0, and I know x is negative 2, that leaves only one variable, so I can solve for that. So I'd have 0 is equal to negative 12 plus 2a, add 12 to both sides. So a is equal to 6. If it asks for the value of b, what I would have to do, well, and it does ask over here, I just couldn't read it right then. If I ask for the value of b, which it does, you need to go up to this original problem And now that you already know what a is, you can, again, a is 6, I know x is -2, and points of inflection always occur on f of x, so on the original graph. So that means 27 is my y value. -2 cubed plus a was 6, x was -2, bx, so -2. And now you can, I'm running out of room here because I'm writing in a marker, but now I can actually solve for b. And jumping ahead because I already have a lot of the work here, I get b is -4. You'll definitely see one like that. Okay, then the next one, you'll really, if it's on a review, make sure that you're actually trying these problems because, they're useful. Okay, the next one, let h be a function that is differentiable. Yeah, differentiable. As soon as you see a function is differentiable, I know it is also continuous. It also says h of 3 is 10, or -10, h of 7 is 10, h of 11 is -10. At least how many zeros? Okay, so sometimes because h prime or f prime is equal to 0, sometimes people automatically think Rolle's theorem when they see any zeros. But this is talking about 0 on h of x. So it's not about rules anymore. This is just a value we're talking about. And I want to know, is it in between others? So you should be thinking IVT. So because this function is continuous, so intermediate value theorem, I'm going to write this strangely, applies as h of x is differentiable, which I don't really care about differentiable for IVT. I care about it being continuous. And if I'm looking at a graph and I see that x is going at -3, I'm going to write this over on the side. I know I'm running out of room, but that's okay. H of 3 is -10, so it's down here. H of 7 is 10, and then h of 11 is -10. I can see I have to, in order to get from here to here and then here to here, I have to at least go up once and then go down again. So at the very, very least, h of x has at least 2 zeros. So obviously you'd be given a little bit more room to write this. That's how you know, because you have a continuous function and it's going from a negative value to a positive value. It has to go through 0. Same thing if you have positive to negative. The next thing, can you determine if the h of x has any horizontal tangents? So this is extending your knowledge a little bit. Horizontal tangents happen when h prime of x is equal to 0. As soon as you see this, you should be thinking, oh, I bet that has to do with Rolle's theorem. So what I'm going to do is say, I'm going to go through the conditions. I know this function is h of x is differentiable. Therefore continuous. I also know that f of a equals f of b, or at least I hope so, because if we're talking about horizontal tangents, right now I can see that h of 3 is -10, but I can also see h of 11 is -10. Therefore, Rolle's applies, because it meets all that condition. And h of x does have at least one horizontal tangent. And I can see up here on the graph, but I actually kind of made one anywhere. I can see right here where h of x has a relative maximum, that it will also have a horizontal tangent at that point. Okay, the next thing, for some c, where c is in the open interval from 7 to 11, is h of c equals -1. This again is a function value. If I'm talking about a function value, I should be thinking IVT. intermediate value theorem. This one's the one that you actually don't always need to write IVT as long as you explain it out, because this is asking you about theorems in particular. What does this one say? I thought it said something about theorems on this one. Maybe not. It's late and I'm getting tired. Anyway, h of c is -1. You can actually go through this process and it just takes a little bit longer if you talk about a function as continuous, so it has to every value between the value it starts with and the value it ends with. Like, you are allowed to explain this one away on the AP exam. If you're using rules, MVT, you have to name them or you would lose some points. Okay, so from 7 to 11, h of 7 is 10, h of 11. And now for the same reasons as up above, because I'm going from a positive value to a negative value, it hits 0, which is what we set up here. It also hits every negative value. So I'm going to do the same thing as we did, where do we do that one? Yeah, it was on this one. The same thing that we explained one of these before. This one, sorry. This one, where I say g of 3, g of x, g of h, that's a good one to, or g of 8. That's a good way to explain both a and c on this back, and say as g of x is continuous, or in this case, as h of x is continuous, and I know h of c, which is -1, is between 10, h of 7, because that's 10, I'm getting it from up here, and h of 11. It doesn't matter that it's going the other direction, like h of 11 and h of 7, as long as -1 is in between them, and this function is continuous, is differentiable. I'm running out of room. IVT applies and guarantees such a value. The next one says if f of x equals the cubed root of x, so I can rewrite right away f of x is x to the 1/3 power. If the rate of change, think about derivative, think about slope, of f at x equals c is 3 times its rate when x equals 1, then what does c equal? Okay, so this is a little bit more work. But if I'm talking about rate of change, I know I'm going to have to find derivatives, so let me do that. Take 1/3. Oops, if I take 1/3 minus 1, I would get -2/3. So this is going to be equal to 1/3 x to 2/3. So right now I know f prime of x is 1/3 x to 2/3. And if you want to write that in some other way and say the cubed root of x squared, that's just fine. So it's saying f prime of 1, if I put 1 in here, I would get 1/3 to the 2/3 would be 1 to the 2/3. If I square 1 and then take the cube root of it, I'm still going to get 1 times 3, still 3. So I get 1/3. Then at f prime of c, what it's saying is that the rate of change, f prime, at x equals c, right here, is 3 times its rate of change at x equals 1. So if I go, the rate of change at 1 was 1/3, 3 times that many, we want 1/3 times 3, we get 1. It's saying what does c equal? So what I want to know is when is f prime of c equal to 1? So I go back over here and I write my derivative, which is 1/3 x to 2/3, and set it equal to 1. In order to get rid of this, I multiply both sides by 3x to 2/3, and I get 1 is equal to 3x to the 2/3. Divide both sides by 3. Now the way that you get rid of a 2/3 exponent is to take both sides, 3, oh sorry, it's hard to see, 3/2 power. Over here I get x. 1/3 to the 3/2 power. I can take 1 to the 3/2 power, so 1 cubed is 1, square root is still 1. 3 cubed would be 27, and then if I take the square root of that, I don't know what it is, so I'm just going to keep this square root of 27. If you want to rewrite this, you can. So if this is like, you know that 27 is the square root of 9 times 3. Square root of 9 is 3. This would be your value of x, or you could say this one. If it's a multiple choice, though, it might be given this way, or this way, or this way. Well, probably one of those. Okay, the last thing, what is the minimum value of the function? Remember the absolute minimum. So minimum value, the entire function. Minimums can happen at endpoints where the derivative is 0. So I actually have to find the derivative. Here I can see I have a product, which means I have to do the product rule. So I'm going to say first, the derivative of cosine plus the second times the derivative of the first. If you had a problem like this, you would definitely be able to use your calculator. So put this all in y1, and then you set it equal to 0. So, well, you don't really have to set it in equal to 0, but in your calculator, put this on y1, and then set your window so that you're going from 1 to pi, so your x min is 1, your x max is pi, and then finding these zeros. If you do so, you find that x, do second, calculate 0, do the left bound, do the right bound, make sure that you push an extra time for guess. You should get x is 1.7, or like x is equal to 1.076. So what you do, if you want the minimum value of the function, I'm going to go back up to f of x, and minimums and maximums can happen at endpoints. So I'm going to try f of 1, f of pi, or where the derivative is 0, where the slope of the tangent is 0, where the horizontal tangent. If this were for response, make sure that you put in more decimal places than just 1.076. If it's multiple choice, which it will be, don't worry about it. F of 1 is 0.540. F of 1 oh, that's weird. I have over here, I have 1.076, and on their thing I have 1.165. So let me check and see if this value is actually right, or if it should be 1.165. Anyway, f of pi should be negative 9.869. And this is what I'm debating. You can see right here, I have something different. So my guess is, I don't have a calculator home with me. So my guess is I wrote this number down wrong, and it's actually supposed to be this. So in your calculator, check. If it's not 1.076, it's the other one, 1.165. So check it, and you probably are going to get negative, or I'm sorry, 0.535. Either way, if we're talking about minimum value, that actually comes here at negative 9.869. If this is all multiple choice, it would say the minimum value of the function is, and one of the choices is going to be pi, and one of them is going to be this value. Choose this one. A function value is always the y value. Somebody will do it, don't let it be you. I'm going to try to make myself available to help if somebody can possibly cover my morning duty, but I just don't know yet. So, good luck. You're going to be great. So, study lots. I know Christmas is coming, but it pays to work really hard, and you guys are really awesome. So, keep it up. Thanks. Oh, this looks scary. It looks like I'm bleeding on my table, but I'm not. That's why I put an extra piece of paper down. Anyway. Have a great night, and I will see you soon. Bye.